Okay, this lesson here I'm going to work on more simplifying with radicals, okay? You have 4 with a square root, put a 2 there over 2x. Remember, it's a de facto 2 if you don't have anything, times 5, and then another square root, and inside you got 6xy to the second, okay? Now here's what you do. You times the outsides first. 4 times 5 is 20. Then you make a parentheses to the half power and you multiply the inside. So I take 2 times 6, that's 12. Okay. Then x times x is x to the second power. And then I don't have a y, but I have a y to the second there. Okay. And now it's all set up. Okay, so bases, you have a 20 times a 12. Then for variables, you have an x and a y. Now 20 is to the first, but it's not in the parentheses, so no distribution. It's just 1. Now the 12 is to the first. That's in parentheses, so 1 times 1/2 is 1/2. Okay, now the x is to the second. It's in parentheses, so 2 times 1/2 is 1. And the y, 2 times 1/2 is 1. Okay. None of them are negative. Now place the whole numbers first, so 20 to the first times x to the first times y to the first, and then the rational exponent at the end, times 12 to the 1/2 power. Okay, we don't really have anything on the bottom, much less a fraction, so cross that out. You're not going to really see what happens there until a couple assignments from now. Okay. Okay, now 20 to the first times x to the first times y to the first. Then you circle that bottom number and turn that into a square root with 12 to the first, which would just be 12. So now we simplify. 20 to the first is 20. X to the first is x. Y to the first is y. And then in my square root, I want to get as much of that 12 out as I can, okay? So I make square root times square root, both 2's. You're looking at the square root list. 12 doesn't divide by 9, it does divide by 4, because 12 divided by 4 gives you a 3. And the square root of 4 then turns into 2. So 2 in front, put a times 2 there, and then a 3 inside. Now 2 times 20 you need to multiply, that's 40, okay? And there's your answer, 40 times x times y times the square root of 3. Okay, next problem, we have a 5 with a cubed root, and inside the cubed root we have 2x to the second, y to the second, times, then we have a 2, a cubed root, and inside the cubed root we have 15x to the fifth and y. So first thing we do, we take 5 times 2, that's 10. Then I make a parentheses. Since they're cubed roots, we put 1/3. Now we multiply what's in the cubed roots. 2 times 15 is 30. X to the second times x to the fifth is x to the seventh. Remember, you add the exponents. Then y to the second times y to the first would be y to the third. Okay. Now I set up my procedure, 6 lines. So the bases, we have 10 times 30, okay, times x times y. So 10 is to the first, but it doesn't get distributed, it stays a first. 30 to the first, 1 times 1/3 is 1/3, okay. Then x, 7 times 1/3. 2 1/3, x to the 2 1/3 power. Remember, that's not a bad thing. Y, 3 times 3 is 1. So none of them are negative. Okay. Now your whole exponents, we got a 1, a 2, and a 1. Remember, that counts. So you have a 10 to the first times an x to the second times a y to the first. Then I have my 30 to the 1/3. and x to the 1/3. Keep circling those bottoms, because now at this point in the problem you need to check your list. Your cubed roots, is 30 a cubed root? No, it's not, and we know the variable's not, so nothing, I can't get rid of anything right now. Okay, now turn those cubed roots back, turn those 1/3 powers back into radicals, into cubed roots. You got 10 to the first times x to the second times y to the first. And then since they have the same bottom, a 3, we just need a cubed root. And inside we got 30 to the first, which is 30. X to the first, which you can just write as x. You can put a 1 if you want. So now you're at the last step. 10 to the first is 10. X to the second stays, and then y to the first can just be y. And then I make my cubed root. I know the x stays inside, but now I want to see if I can break that cubed root of 30 into 2 separate cubed roots. So cubed roots, 30. You divide by 27, and you divide by 8, and I don't get anything, so that 30 will stay in the cubed root. Okay? If you can't get it to divide, then nothing comes out. Okay, next page. We have a square root, and inside the square root we have 72x to the third y to the second times, and we have another square root, 10x y to the third. Okay. There's no outside factors, so you go right to your 1/2 power, and you take 72 times 10, which is 720. X to the third times x to the first is x to the fourth. And the y is y to the second times y to the third is y to the fifth. Remember, you're adding the powers. So you have 720 times x times y. So 720 to the first, 1 times 1/2 is 1/2. Then x, 4 times 1/2 is 2. Then 5 times 1/2 is 2.5. Okay, none of them are negative. Okay, your whole exponent, you have a 2 and a 2, so you have x to the second times y to the second. Now you go back and cross those out. Now put your rational exponents, times 720 to the 1/2 times y to the 1/2. Now circle the bottom of the rational exponents. See if you can get rid of those right now. Is 720 on your perfect square list? No, it's not, so that's going to stay. And same with the variable. Okay, just to check. Cross that out. Those will be used at some point. Okay, so now we turn those back into radicals. So we have the x to the second times the y to the second, and then the bottom has a 2, so I need a radical of a degree 2. And inside the just one of them, if they're the same, you just need one of them. 720 to the first, which is 720, and then y to the first, which is just y. Okay. So you got x to the second, y to the second. Now we try to simplify the inside of the radical. You can't simplify the variable, you never can, using this method. But the square root is 720. Let's see if we can rewrite that in 2 square roots. Be patient. Nope. Divided by 196. Nope. Nope. Ooh-ha, 144 and 5. So this 144 becomes a 12. So 12 goes out here, and 5 goes in here. Okay, so that's your answer. 12 times x to the second times y to the second times the square root of 5y. Okay, next problem. First, you got outside factors. 3 times 5 is going to be 15. Oh, sorry, I need to read it. So 3 fourth root of 2x to the fifth, y to the fourth, times 5 with a fourth root of 32 x to the third y. Okay, so 3 times 5 is 15. Now I make my 1/4 power out of that. And then 2 times 32 is 64. X to the 5th times x to the 3rd would be x to the 8th. And then y to the 4th times y to the 1st would be y to the 5th. So your numerical basis, you have 15 times 64. In the variables, you have x and y. So 15 stays to the first. It's not part of the parentheses, so it stays there. 64, 1 times 1/4 is 1/4. On the x, 8 times 1/4 is 2, just 2. And 5 times 1/4 is 1 1/4. None of them are negative, so don't be moving them. Okay. Alright, circle your whole exponents. Those all go in the front. 15 to the first times x to the second times y to the first. You just position those in the front. Okay, and then you have 64 to the 1/4 times y to the 1/4. Now circle the bottoms and go to your sheet and see if they simplify right now. So 4th root, 64 is not there, so that can't be simplified right now. Y to the y is not going to be there either, so they stay. Alright, now turn the 1/4 powers, those go back into 4th roots. So you got your 15 to the first, you got your x to the second, you got your y to the 1, but when you get to the rational exponents, you make one root, because all you have is a 4. 64 to the first would be 64, y to the first would be y. Okay, now simplify. 15 to the first is 15 times x to the second. Y to the first can be just y. And then I make my radical with a 4. We know the letter's staying in there. Okay. Now, the number that's in there, you need to see if you can pull some of that out. You can't pull it all out. If you can pull it, get rid of it all, you would have got it to work up here. Okay, so 4th root. So 64 divided by 81. You're on this list. You got to know what the list you're looking at. You got 2s, 3s, and 4s. No. It's either 16 or we're leaving it, but 16 works. So I've got 4th roots, 16 in the first, 4 in the second. The 4th root of 16 is 2. So I put a times 2 here and a 4 in there. Now 2 times 15 you want to multiply. So that'd be 30. So 30 times x to the second times y, and then the 4th root of 4y. Okay, now, game changer. Now it's division, but it's kind of the same principle. It's square root, so you write it to the 1/2 power. Now make a line. 18 divided by 2 is 9. Well, where do we put 9? You put it on top. X to the 5th, remember how you divide exponents. You get rid of the smaller one and subtract it from the top, and that would be x to the second. So the bottom's empty. Okay. So what we have is 9 times x. So 1 times 1/2 is 1/2. 2 times 1/2 is 1. Okay. None of them are negative. Put your x to the 1 first, then 9 to the 1/2 power after that. Now, this is why it's very important you circle that bottom and check your list, because the square root, it's a 2, so I'm looking at the list of square roots. 9's there. Square root of 9's 3, so you cross out the 9 and the 2 and put 3. Now you have 3 to the first. Okay. Okay. So you have x to the first times 3 to the first. And then you just simplify. I would simplify the whole number first. 3 to the first is 3. X to the first is x. And you don't have a radical. Okay, because you got rid of your rational exponent here. That's why it's important you check that. Okay, next one, we have the cubed root, and in the cubed root we have 162 y to the fifth over y to the third. That's all in the cubed root, so it's all expressed as a 1/3 power. Now 162, okay, wait a second, I don't think I did that right. 162, I don't think I wrote that down right. My bad. That needs to be a 6 down there. Or no. We'll keep it. Okay, we'll keep it. Okay, so 162 stays where it's at. And then y to the fifth, y to the third. You get rid of the y to the third, subtract it from the top. So y to the second. So you don't have anything on bottom. So you have 162 times y. 1 times 1/3, 1/3. 2 times 1/3 is going to be 2/3. Okay. All right, so you don't have any whole exponents, so you just put 162 to the 1/3 times y to the 2/3. Okay. All right, you're not going to do anything there. Now, check your list, check your thirds, see if you can cross anything out right now. 162 is not there, okay, and y certainly isn't there. Okay, so now I don't have any holes. I just make my root with a 3. 162 to the first is 162. Y to the second would be y to the second. Okay, so you just make a cubed root. You know the y to the second stays in there, but what about the 162? Well, you make that into 2 cubed roots. Okay, so 162 divided by 125 decimal. 162 divided by 64 decimal. 162 divided by 27, 6, okay? Remember, they're cubed roots. 27 and 6. So the cubed root of 27 is equal to 3. So we put 3 out and then 6 in, okay? And there you have it. This works every time. Okay, now I have 2 separate square roots, but it doesn't change the problem. It's done with 2 separate ones if it was one whole. On top you have a square root of 50x to the 6th. On bottom you have a square root of 2x to the 4th, y to the 4th. Okay, so you are still going to write that all as a half power. You can do it with 2 separate just like you do it with one whole. That's the theorem. 50 divided by 2 is 25, so I put 25 on top. Now remember what you do at the x to the 4th. You subtract it. Okay, 6 minus 4 is 2. And on bottom, there's nothing, you'll go with the y on top, so we just put a y to the 4th on bottom because there's nothing to divide by y to the 4th, so it just stays on bottom. Now, for the first time, you're going to have something on bottom. 25 times x on top, y on bottom. Okay. So 25, 1 times 1/2 is 1/2. X, 2 times 1/2 is 1. And then 4 times 1/2 is 2. Okay, so you position the holes, okay? No, none of them are negative. So x to the 1, y to the second. Remember, you put it on bottom. Now the fractional exponent, you just write over here. Now, circle the bottom and see if 25 appears on the square root list. Sure it does, it's 5, so you cross out 25 and the 2, and you now have a 5 to the first. Okay, so that's why it's very important to check that. Now, for the first time you actually have an exponent on the bottom. Is it a fraction exponent? Is it a rational exponent, a fraction exponent? No, it's not, so we don't have to worry. If it would be y to the 1/2, that's a problem we need to fix. That's what this step is for, but it's not. Okay, I don't think I have any fraction exponents. I mean, I have my x to the 1, I have my y to the second, and I have my 5 to the first. None of them had fractions with their exponent. I was able to get rid of the fraction right there. Okay, So I don't need to make any radicals. You only make radicals if you have fractions. So 5 to the first is 5, then times x, and then y to the second. Okay, last problem in this video. On top we have a cubed root, degree 3, of 135 x to the 8th. Now on bottom we have a cubed root of 5x to the second, y to the 12th. So again, you rewrite that all as 1/3 power, but now you simplify by dividing. 135 divided by 5, 27, so you position 27 goes on top. X to the 8, x to the second, so we subtract the smaller from the bigger. X to the 6, and that's on top. And then on bottom we have the y to the 12th. There's nothing on top to subtract, so the y to the 12th sits on the bottom. Okay, so the base is on top. You got 27 times x, and the base on bottom is a y. Now obviously all those exponents get multiplied by 1/3, so 1 times 1/3 is 1/3. X, 6 times 1/3 is 2 whole. 12 times 1/3 is 4 whole. Okay, none of them are negative. Okay, now circle your whole exponents and put them first. And then just carry the base with the rational exponent over here. Now circle the bottom of your rational exponent and go to your sheet. Now you're looking at the 3 list. Is 27 there? Yes, it is. It's equal to 3. So we cross out that because that is the cubed root of 27, which is 3, and it's now 3 to the power of 1. Now you do have a exponent on the bottom, a 4, but it's not a rational exponent, it's a whole exponent, so we don't need to worry. Okay, so we got x to the second, 3 to the 1. I don't think there are any more rational exponents, meaning fraction exponents. Okay, I eliminated them all. So 3 to the first is 3, kind of they want you to do that one first, and then x to the second, y to the fourth. That's it.